guys, so here we are again, ready for a new lesson. Sorry. Today we're going to solve linear systems algebraically again. This time we're going to use elimination. Sometimes it's called addition. So there's a couple different names for this method. Elimination and addition seem to be the most used though. So here we go. Our goal is you will solve systems algebraically using elimination and then be able to identify when it is easiest to solve using either substitution or elimination. So you want to be able to look at the equations or the problem and tell me which method is easier to use and why. So that leads us, of course, to our question of the day, our QOD. So how do you know when it is easier to use the elimination method versus the substitution method, and vice versa, of course, to solve systems of equations? So that's your question for tonight. Again, we'll pause on the end and talk a little bit about it at the end. Here we go. There's 5 steps this time to solving systems using elimination. The first step is we want to arrange all the both equations with like terms in columns. So I want the x's, the y's, and the constants all to be in a column. And again, I'll show you this on the next slide. Not enough room to go over the steps and the problem at the same time and be able to have you guys be able to see it. So here we go. Step 2, I'm going to multiply if necessary. You don't always have to do step 2. And again, we'll talk about that later in the presentation today. Step 3 is I'm going to add the equations together. Now, sometimes I might want to subtract them, but on the most part, I'm going to just add them together. Okay? That's it. Just add them together, both equations. Once I add them together, that's going to eliminate one of my variables. One of my variables will be gone, and then I'm going to substitute my answer from that back into one of my other equations, back into one of the equations. And then, of course, the last one is I'm going to check my solution. Okay? 5 very simple steps. Okay? Great. So we're going to move on and actually do some problems. Here we go. I wanted to give you guys a little bit of a time to write this down, although I do know you can pause. I don't know why I keep thinking that you guys can't push the pause button, but here we go. So arrange them in columns. That was first step. So notice how all my x's are here in this column, and all my y's are here in this column, and my constants are here in this column. So that's what we want. That's what they mean by arrange like terms in columns. So I want my x's underneath my x's, my y's underneath my y's, and my constants together. So I'm going to look at this, and if you look, I actually could substitute this, use substitution on this equation, because in my first equation, they're all factors of 2. So I could simplify and solve for y in the first equation. But then if you look at it a little closer, I notice I have a negative 2y and a plus 2y. Well, if I add those together, what do I get? If I add negative 2y plus 2y together, I think I get 0. So let's try it. So 4x, so I'm going to add them. 4x plus 3x is 7x. And negative 2 plus 2 is 0, so there's no more y. Y is gone. And 2 plus 12 is 14. Okay? Now I solve for x. Divide by 7. X equals 2. Okay? Perfect. Notice I didn't have to multiply by anything. I just added my equations together, got down to one variable. That's it. Okay? Now, that's my x term. I have to find my y term. So I'm going to take my x, and I'm going to choose one of the equations. It does not matter which equation I choose. In fact, I'm going to do both of them for you so you can see that I get the same answer no matter which one I choose. So if I choose A, 4x minus 2y equals 2. I'm going to take x which is 2, and substitute in. So that's 4 times 2 minus 2y equals 2. So I get 8 minus 2y equals 2. You guys know how to do this now. We're just solving. Subtract 8 from both sides. Negative 2y equals negative 6. Divide by negative 2. And y equals negative 3. Oh, positive 3. Okay? That was pretty good, wasn't it? It's messed up my minus signs. Almost reminded myself of you guys sometimes. Okay? Now I'm going to take my second equation, which is 3x plus 2y equals 12. So again, wherever there's an x, what am I putting? I'm putting 2 again. Same thing. So I get 3 times 2 plus 2y equals 12. Now I should get 3 again, correct? So it should, if I'm solving for y, I should get the same answer. So 6 plus 2y equals 12. Subtract 6 from both sides. 2y equals 6. Divide by 2. And y equals 3. Awesome. So again, it doesn't matter which equation you decide to pick to plug it back into. Just pick one of them and substitute it back into. Usually I like to choose the one that's simpler. In this case, there really wasn't one. But sometimes, like, one of the equations will have great big huge numbers and the other one won't. So I'll choose the one with the smaller numbers. Just, you know, whichever one makes you guys feel more comfortable, or you just feel more comfortable with, okay? It's just up to you. So my answer is 2, 3. You can substitute it back in. 4 times 2 is 8. Negative 2 times 3 is 6, negative 6. So 8 minus 6 is 2. So it works there. We could do the same thing here. 3 times 2 is 6. And 2 times 3 is 6. And 6 plus 6 is 12. So it checked out for both of these equations. And our answer is 2, 3. Okay? So here we go. And I do want to just say, I think most of you guys will be going, oh, that's so much shorter than substitution. Yeah. Sometimes it tends to be shorter than substitution, but sometimes this one is much harder than substitution, and you have to do a little bit more work. So, hence your QOD today. Okay, here we go. So, the first thing was that I had to have them in columns, right? My x's and my y's. So I need to have my x and my y both on the same side of the equal sign. So I need it on that second equation, I need to move the 3x. So I'm going to do subtract 3x on both sides, right? So I get negative 3x minus 5y equals negative 21, and 2x plus 5y equals negative 11. Right? So I got my first equation and my new second equation. And I'm going to have you guys finish this problem. Okay, so don't freak out, just write it down. We're going to do some more problems so you can see how to do it. I know I've only done one so far. It's okay, but you guys are going to finish this problem, okay? And bring it in tomorrow with your QOD. All right, here we go. Next problem here. Again, we're going to solve. We are in columns already. Okay. If we look at the, my coefficients for each one, so if we look at this one, I've got a 2, a negative 3, and a negative 4. No multiples of each other. I have a 6, a 3, a negative 9, and an 8. No multiples of each other. There's no way I could solve this equation using substitution. So I have to do eliminate. Eliminate. Oh, I'm speaking so well today, you guys. This is where I'm going to multiply, because I don't have two of the same thing. I can either multiply, but I can look at it and I can say, oh, 2 is a multiple of 6, and 3 is a multiple of 3, 3 is a multiple of 9. Whoa. So I can either multiply the top number by 3, that's what I can do. I can multiply the top number by 3. 3 will give, 2 times 3 is 6, and 3 times 3 is 9. So I'm going to take my top equation, and I'm going to multiply by 3. Okay? So, and that's multiply everything, even what's on the other side of the equal sign, everything by 3. So 3 times 2x, we're just going to kind of distribute here. 3 times 2x is 6x. And 3 times negative 3 is negative 9y. And 3 times 4 is 12. So if I look at it, if I add these together, I'm going to get 12x minus 18, right? So I'm not getting rid of any of my variables. But if I subtract the two, if I subtract these two, I should get rid of one of my variables, right? I'm going to get rid of my x for sure. 6 minus 6 is 0x, or 0. Okay? Negative 9 minus 9, oh, that's plus 0y, equals 8 minus 12, negative 4. So this side, we already know 0x plus 0y is just going to be 0, equals negative 4. Does 0 equal negative 4? Well, no. No, it doesn't. 0 cannot equal negative 4, ever. So what type of solution do we have? This is one of our, we don't have a point this time, so this is either going to be no solution or infinitely many solutions. This is going to be the same line, or they're going to be parallel. So because 0 cannot equal 4, we have no solution. Right? We know that's from your QOD from last time. We know that this is what it looks like algebraically when I have no solution. I have a number that, two numbers that cannot equal each other. Right? So that's no solution. Good job, you guys. So let's move on to the next fractions. Not too bad. I kind of like that problem. So this one says, oh, look, our directions changed. It says solve the linear system using any algebraic method. That means I can either use substitution or I can use elimination. It doesn't matter. I can use either one and solve. Cool. I can use either one. So let's see, what should we do on this one? Oh, geez, it looks like I can do either one, elimination or substitution, because I could solve the top one for x or y, and it looks like I could solve the bottom for x or y, because 6 is a multiple of 24, so I could divide by 6, and that would work. Okay, so, or I could multiply the top row by 6, and then add them together. So let's go ahead and do elimination. So I think I'm going to like that one. Let us multiply the top row by 6. So distribute. 6 times x is 6x. And 6 times negative y is negative 6y. And 6 times 4 is 24. So now I add them together. Negative 6x plus 6x is 0x. 6 minus 6, oh, plus 0y. Negative 24 minus 24 is 0. So I get 0 equals 0. Awesome. From what we learned last time, what type of solution do I have? That's right, I have infinitely many solutions. Right? Or we can call it IMS. Infinitely many solutions. Okay? Why? Because they're the same line, so they intersect at every point along the way, as you guys found out in our first, when we graphed these, right? They're the same line, all the points intersect forever. So we have millions of solutions for this. Great. Awesome, awesome, awesome. Okay. So the last one, I'm pretty sure this is the last one. Let me look. Oh, yeah, this is the last one. Great. Solve the linear system of system using any algebraic method again. So we're going to do the same one. And I'm going to look at this. Again, if I'm doing elimination, I need to put them in columns. To put them in columns, it looks like all I have to do is take my top equation and flip it. So I would get 3x minus 3y equals negative 33. Okay, so what can I do? If I wanted to do elimination, let's see what work we have to do for both of them. Okay, so if I wanted to do elimination, I would take this one, and I want to get rid of y, I think. I would take this equation and multiply by 3. And I would take this equation and I would multiply by 2. So I'd have to multiply twice. I'm not sure I like that. But I did notice as I was rewriting this that 3, 3, and 33 are all multiples of each other. So I could take this equation, 3x minus 3y equals negative 33, and solve for x, and use this substitution method. And I think that's what I want to do. 3x equals 3y minus 33 divided by 3. And x is going to equal y minus 11. And then I'm going to substitute this back into my second equation wherever there's an x. Okay? So that's what I would do. But guess what? You guys get to either finish what I did or go ahead and do the elimination method for on your QOD. So 2 problems tonight on your QOD along with your question. So go ahead and finish this one up and finish the other one up. And again, on this one, I don't care which way you do it. I just wanted to show you that I could do it either way, okay? Because that should help you with your QOD, by the way, deciding which method is going to be easier for which ones. Here we go. Speaking of our QOD, how do I know when it's easier to use elimination method versus the substitution method to solve my equations? Okay? Answer that question for me. Finish 2 problems for me, and you're done. Done, done, done. Good and done. Okay? I will see you guys tomorrow in class. Have a great night.